All right, so we should verify that we had the same formula. So can you guys give me a... Okay, fine, I'll change my bracket.
Now that you're half and half.
There we go. Apparently we're denoting vectors with parentheses.
Okay.
Okay, so what should I put in for the n vector? What's your guys' favorite set of vector coordinates?
Some standard base.
A, B, C.
Let's go A, B, C.
Yes.
So I'm going to say, all right, if n is coordinate-wise A, B, C, and I'm dotting that with x minus x naught, y minus y naught, and z minus z naught. And this is supposed to equal 0. Why is this supposed to equal 0?
We're wanting, perpendicular.
Yeah. Because we were trying to do something like this, right? We had a point P naught, and an arbitrary point P, some vector in the plane, something that sticks straight out. That was our n.
Yeah.
Right? Okay, so what do I get when you do this dot multiplication?
A times x naught minus, x minus x naught. Plus,
Okay.
plus b times y minus y naught. Plus c times z minus z naught.
Equals 0. Okay, done. Okay, we could certainly distribute because they're all scalars. Let's see. Sure, what the hell. So I've got ax minus ax naught plus by.
Minus by naught.
Sorry, I'm so used to teaching algebra that I'm not doing. Minus by naught plus cz minus cz naught is 0. And then to get to our old formula, right, we'd yeah, I actually probably should only have distributed this one to get to the old formula, right?
Yeah, I was gonna say,
Solve for z.
go back up.
Yeah, here I really wanted to solve for z, right? So let me undistribute the first two. And now I want to move the z to the other side, right? Okay. So I at least buy that this is the same formula in a different context, right? So what's the advantage between, one or the other? Like, why would I pick one or the other? Why would I want one or the other?
The new one would be good if you had 2 points.
Yeah, the new one's nice if I've got 2 points.
A point and a line.
Actually, a point and a normal vector, right?
Yeah.
You see that? I'll have a good way to get normal vectors later. Maybe even today. Okay, but for right now, if I've got a point and a normal vector, right? This thing's awesome. If I've got 2 slopes, right? And an intercept, then this one's cool. This one's easier for me to interpret a little bit, right? Because I know the slope and the x and the slope and the y, and I can kind of think about what those mean in terms of like houses or whatever, right? This one's nice if I want to know what's perpendicular, right? Because I can just read that normal vector off right here. You guys see that? In fact, even after I distributed, I could read that normal vector right off. You guys see that?
Yeah.
So that normal vector is always going to be there, and it's just going to be the components on, or its components are going to be the coefficients on, yeah, x, y, and z, right? You guys see that?
Yeah.
And they're going to be exactly where you expect them to be, right? There's no rearranging. The I components on the x, the j components on the y, and the k components on the z. You guys see that?
Yep.
In fact, I could even read those off here, right? What's your normal vector up here?
Sx, sy.
I promised I was going to do the other thing. Sx, sy,
Z naught.
and
One.
Oh,
for
0.
Z naught.
and
1.
and
No, SC.
Oh, -1?
-1. The Z was on this side.
Oh.
Oh.
You guys go with that? Little subtle, but it's all there. You just move everything to the other side, and then you can read off that normal vector. Cool? What does the normal vector do? It tells you about things that are perpendicular to it. Right? Cool? Questions, thing? Okay.